Okay, students, this is how to graph a rational function. So this is from chapter 8.3. It is practice C, number 5. So the problem is f of x is equal to the fraction 2x squared plus 3x minus 9, all divided by x. And I need to graph this rational function. There's our function. Okay. So I have next to me, and I think you should get out too, that paper that I handed out called Graphing a Rational Function, and we're just going to take it step by step. So step number 1 is I want to plot the x-intercepts. X int. So when I want to plot the x-intercepts, my x-intercepts are going to be when y is equal to 0. You can see that on the graph. Any intercept on the x-axis is going to be when y is equal to 0. So why don't I just set my function equal to 0? And if I set my function equal to 0, really all I'm concerned about is that my numerator be equal to 0. Because if my numerator is equal to 0, my function is going to be equal to 0. So I have 2x squared plus 3x minus 9. Well, I need to factor that. So I'm going to use the Mr. LeBron method. I'm going to go 2 times negative 9. I'm going to do that in color here. 2 times negative 9 is negative 18. And are there 2 factors of 18 that are negative 18 that are going to get me a positive 3? Well, let's see. I think there are. I think I'm going to have, how about 6 and 3? Positive 6, negative 3 will give me a negative 18 and will give me a positive 3. So I'm going to do this factor out the Mr. LeBron method. I'm going to have 2x squared plus 6x minus 3x. My 6x and minus 3x, they correspond to the positive 3x right there. Minus 9. And why don't I just go ahead and group those? And remember, when you're grouping with a negative sign, you have to make this a positive right there. So from this left term, left binomial, I'm going to pull out, how about a 2x? And that leaves me with x plus 3. And how about from this other one, I just pull out a 3, and I get x plus 3. So that means I have 2x minus 3 times x plus 3. So if I have x is equal to 3 halves, or x is equal to negative 3, those are places where I will have y is equal to 0. So why don't I just go plot those right now? So if x is equal to negative 3 halves, I'm going to have right there, I'm going to have a point, an x-intercept. Whoops, wrong side. Sorry. Glad I caught it before I got too far in this video. X is equal to positive 3 halves right there. And x is equal to negative 3 right there. Those are my 2 x-intercepts. So I'm thinking about how I can make this work so you can read it as a printout as well. So what I'm going to do is I'm going to clone this page. So we'll have that page right there. Now I'm working on the cloned page. And what I'm going to do is I'm going to erase all the work that I did for the x-intercept. You'll have that on the other page. It'll be there. Sorry for the delay. You can fast forward if you want to, but not too far. Okay, that way I still have my graph. So I'm going to say my x-intercepts, I'm going to put that right here for my number 1, were positive 3 halves and negative 3, and they're still on the graph. Okay. Now let's go to number 2. My y-intercepts. Well, I'm going to have a y-intercept when x is equal to 0. So I could look back at my function, and I could plug in a 0 here. I could plug in a 0 here, and I could plug in a 0 here. Ding, 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 ding. Red lights go off. Cannot plug in this 0 here Because if I do, I'm going to have 0 as a denominator, and that's not going to work. That is forbidden. So, since I can't do it, I have no y-intercept, which is going to lead me to my next point, which is number 3, sketch in the vertical asymptotes. So number 3, I want the vertical asymptotes. So 3, I'll go vert A-S-Y-M-P, very strange word, but we love it. Vertical asymptotes. Vertical asymptote is going to be where my domain is completely restricted. And where my domain is completely restricted is where x is equal to 0. So in this case, I can see very clearly that, that I'm going to have a vertical asymptote at x equals 0. Now, maybe in another problem here, we're going to make this function in what we call lowest terms. We're going to factor the numerator, we're going to factor the denominator, and there might be some common factors that we can factor out, in which case there will still be a domain restriction, but instead of being a vertical asymptote, it's going to be a hole in the graph. I might have one that I'll be able to show you. You don't need to worry about that too much, but for right now, where x is equal to 0 is going to give us a vertical asymptote, so I'm going to come over to my graph, and I'm going to draw in my vertical asymptote right here. I'm sketching that in. Okay, you can all see that. So the vertical asymptote is at x is equal to 0. My next question says, sketch in the horizontal or oblique asymptote. Well, how do we find the oblique asymptote? So let me clone this again so I can do some erasing and we can do some work. Okay, so now we're on that page there. I'm going to erase all this stuff since we have it on the other slide. I want to keep my graph. There's that. There we go. Okay. So the first thing is we want to remember we're only going to have one horizontal or one oblique asymptote. You're not going to have both a horizontal and an oblique. You're not going to have two obliques. You're not going to have two horizontal. It's going to be one or the other. And if my fraction is proper, okay, x over x squared, that is a proper rational function. Proper means light weight is on the top. This is x to the 1. Heavier weight is on the bottom. You got the heavier person carrying the lighter person. So that is proper. That makes sense. It's proper. If it is proper, the horizontal asymptote, horizontal ASYM is equal to 0. It is the x-axis. Always. If you have a proper rational function, the asymptote is 0. But we do not have a proper rational function. We have a heavier weight above a lighter weight. Let's look at that one. Improper is where it is not light over heavy. One form of improper is that the powers are equal. So if I had the rational function 2x squared over x squared, now that's a bad one. Let's call it 2x squared plus 3 over x squared minus 2. That looks a little bit better. My powers are equal. That is also improper. It's still improper. But because they are equal, it's very easy to figure out what the horizontal asymptote is. The horizontal asymptote, when the powers are equal, is simply the leading coefficient of the numerator divided by the leading coefficient of the denominator of the highest power. So it would be 2 divided by 1. It would be, I would have a horizontal asymptote at y equals 2. But, as you will notice, in this case here, it is improper, but it's improper in even a more severe way because I have they're not equal, I have a heavy over a light. And that calls us to do a little bit extra work. So I'm going to erase all this again here. Go back to here. What we have to do here is we have to do some polynomial long division. I'm sorry, that's what we have to do. I need to transform this rational function into using polynomial long division. So I'm going to divide x, and I'm going to put x plus 0, just because I like to have the power of x and then a constant. My constant here is 0. And I'm going to divide that into 2x squared plus 3x minus 9. Now remember, you only have to do this polynomial long division when your highest power of your numerator is greater than the highest power of your denominator, and in this case it is. So how am I going to do this division? Well, let's start out with we'll have 2x. So 2x times x is equal to 2x squared, and 2x times 0 is plus 0x. My 2x squared cancels out, which is how I designed it. And now I subtract. Remember, when you're doing polynomial long division, you subtract. So I'm going to have 3x minus 9. Well, I also need to do a little bit of work here. So I'm going to go plus. I'm going to go plus 3. 3 times x is 3x, which is what I designed. And 3 times 0 is 0. 3x's cancel out because I'm subtracting them. And I have minus 9. So what I'm going to have is, as the result of my polynomial long division is 2x plus 3 plus my remainder of minus 9 over x. The part of that that I am concerned with is just the quotient. I am not concerned with the remainder. I'm not concerned with the divisor. I'm not concerned with the original polynomial. What I'm concerned with in determining my oblique asymptote is the quotient. Because as x approaches infinity, this part, the remainder, gets closer and closer to 0. It becomes unimportant. The only thing that becomes important is my quotient. So how am I going to graph 2x plus 3? It's not that hard. I know that my function of the equation of a line is y is equal to mx plus b. Well, I have a b of 3, so I know I'm going to have a y-intercept right here at 3. Remember, this is an asymptote, so don't get too worried about the fact that it's crossing your vertical asymptote. It's an asymptote. It is not part of the function. So now I have to have a 2x, so it means I'm going to go over 2. So I have my y-intercept right there at y equals 3. Please go away. Come on, go away. There we go. And I have a slope of 2, so I'm going to go rise over run, up 2, over 1, up 2, over 1, up 2, over 1, and I can kind of see it in my line is going to come in, my asymptotic line. I'm sorry it's not very straight, but that's what my asymptote is going to look like. It's going to be the line 2x plus 3. While you were gone, I decided to write it in a little bit more neatly, and I had the smartboard graph it, so we have a much nicer looking asymptote. That is an asymptote that is not part of the graph. Now, every once in a while, you can have a function cross a horizontal or oblique asymptote. It happens. It's okay. It can never happen with a vertical asymptote, but it can happen with a horizontal or oblique asymptote. And the way we find out whether our original function, which I have brought down here, is ever going to cross my horizontal asymptote there, is I'm just going to set them equal to one another. Because if I find the point that where my original function and my asymptotic function are the same, then I know that it crosses right there. So let's just try that. So I'm going to make that equal to 2x plus 3. I will multiply both sides of my equation here by x. So I'm going to have, that's going to cancel out. And I'm going to have 2x squared plus 3x minus 9 is equal to 2x squared plus 3x. And I can see right now that that's going to be kind of nonsensical because I have 2x on both sides of this equation, 2x squared on both sides of this equation, that goes away. I have positive 3x on both sides of this equation, that goes away. And I have negative 9 equals 0, which it doesn't. So no cross of horizontal, C-O-N-T-A-L, asymptote. Now, the final part of this is that I want to plot a few points. I want to plot a few points in each region, and the regions are defined by my vertical asymptote. That's what defines my regions. Well, I have a vertical asymptote on the y-axis, so I only have two regions. I have one region to the left of it, and I have one region to the right of it. So let's plot a couple of points. Well, initially I'd look at it and say, well, what about 0? Because 0 is always an easy point to use. Of course, forgetting completely, I can't have 0 because 0 is my vertical asymptote. So x cannot be equal to 0. Well, what about when x is equal to 1? Okay, so when x is equal to 1, that's a pretty easy one to do. That would give me 2 plus 3 minus 9 over 1. So 2 plus 3 minus 9, what's that? 5 minus 9, so that would be negative 4, right? Negative 4 over 1. So at 1, I'm going to have a point at negative 4. Now don't forget, I've already plotted my my x-intercepts right there at 3/2 and at negative 3. So that's another point that I have right there for my graph. And then let's look at what happens when x equals 2. I'm trying to make it easy on myself. So x equals 2, that's going to be 2 times 4, and that's going to be 3 times 2 is 6, and that's going to be 9, so that would be 8, plus 6 would be 14, minus 9 would be 5, right? So at 2, I'm going to have a point at 5. So I've got one region kind of going there, okay. What about the other region? Well, how about if we do x equals negative 2? So if I have negative 2, that's going to be 2 again times 4. But this is going to be negative 2 minus 6 minus 9. So that's going to be 8 minus 6 is 2 minus 9 would be that would be negative 7, but I forgot. I need to divide it by negative 2. That's going to be positive 3/2. So at negative 2, I'm going to have one at positive 7/2. That's 3.5. So right there, I'm going to have one. And I forgot that when I had it as positive 2. I forgot to divide by 2, so it's not going to be at 5, it's going to be at 5/2, which would be right there. All right, and let's get one more in the region. Let's use negative 4. So that means this is going to be 2 times 16 minus 12 minus 9, and I'm going to be dividing by negative 4. So what's that going to be? I'm going to have 2 times 16, which is going to be 32, minus 12, minus 9, and then I'm going to divide that by 4, by negative 4. So negative 2.75. So at negative 4, I get almost to negative 3. So right about there. So if I'm looking at this, I'm not going to make you graph it, but we know we have the vertical asymptote and we know we have the horizontal asymptote. So I'm going to say this is going to look something like this. Here's my vertical asymptote. I'm doing my right region there, and it's coming up. It's going through the points that I plotted, and it's going to approach the horizontal asymptote. It's not going to cross. And then on the other side, again, I have the vertical asymptote is the y-axis, and I have the horizontal asymptote here. So I'll start on the horizontal asymptote, and I'm kind of coming up. And I'm getting through my points, and it's not going to touch my vertical asymptote. I think that's what the graph is going to look like. So let's take a look. So I already plugged it in here, so I'm going to go zoom 6, and what do you know? Looks pretty good. That line that I put in there, the asymptote is not part of the function. I just wanted to put it in there so that you could see the asymptote. So that pretty much does the whole thing. If we do this in a test or a quiz, not going to make you sketching the graph unless I give you the option to use your calculator.